Hello friends, in this video tutorial we will going to talk about the enzyme kinetics. This video will going to be the first video lecture of enzyme kinetics where we will going to derive the Michaelis Menten equation. Okay, so this video will also be the first video of a video lecture series where we will going to talk about the enzyme kinetics. Okay, so let's start. So now my question is, what comes in your mind when you hear the term kinetics? So we have already heard about the kinetics in our class 12th, where we have talked about the chemical kinetics, right? And chemical kinetics tells us about the rate of the chemical reaction, right? Similarly, in enzyme kinetics, it tells us about the rate of the enzyme catalyzed chemical reaction. Okay, with the help of enzyme kinetics we can calculate the reaction rate, okay, and also the effect on the reaction rate on varying the concentration of the reaction. Okay, meaning, first of all, we all know that the activity of the enzyme depends on the temperature, depends on the pH, depends on other various important things, let's say product concentration, right? So on changing those situation, how the enzyme, the rate of the enzyme catalyzed chemical reaction changes, we can easily investigate it with the help of the enzyme kinetics. Okay, so the main pillar of the enzyme kinetics is the Michaelis Menten equation. Okay, if you know it very well, then enzyme kinetics will be very easy for you. Okay, so first of all we will going to derive the Michaelis Menten equation. Although it is not required for you for your university exams along with for your entrance exams too, because they do not ask you about how the Michaelis Menten equation is derived. They just want the equation. They will give you the mathematical problems to solve. But still I am recording this video because there are various important small point available inside the Michaelis Menten equation derivation that may come in your exam in the form of MCQ. Okay, so I would like to recommend you that please don't try to, if you want then you can, okay, but if you just want to learn what is important for your exam, then I would like to recommend you, please note the point that I will going to mention when I will talk about the entire thing, but it will be not necessary for you to practice the entire how the equation is derived. Okay, so first of all, Michaelis Menten equation was described by Leonard Michaelis and Maud Menten. Okay, and it can tells us about the kinetics of many enzymes, but there is a condition. That is the first point you should remember, that Michaelis Menten equation is only applicable for that system where the concentration of the enzyme is much less than the concentration of the substrate. Okay friends, meaning is enzyme concentration will be here the limiting factor. Okay, what does it mean? Let's try to understand. That simply means after some time, when the enzyme will be fully saturated. What is the meaning of this saturation? Saturation means, we all know that in enzyme there is a particular part named active site where substrate binds and ultimately converted into product, right? So when the enzyme, all the enzymes will be saturated, that means there will be no active site left in the enzyme, okay, that can interact with the new substrates. Okay, so that is the idea. So the reaction system where the enzyme concentration is much lower than the substrate concentration, we can use Michaelis Menten equation to study the kinetics of that particular enzyme catalyst reaction system. Okay, so the relation between the substrate and enzyme concentration was proposed in 1913 by Leonard Michaelis and Maud Menten. Now it is important to understand. Okay, so now the reaction scheme is, first of all, enzyme will react with substrate and it will give us the enzyme substrate complex. Then this enzyme substrate complex will give us the enzyme plus product. Clear? So now here you may think that you have written here reversible sign, but you have not written here any kind of reversible sign. Why is this so? Because our Menten proposed or assumed a condition, that is, during initial stage of the reaction the concentration of the product is negotiable. Okay, and that is why the reverse reaction, that is from enzyme and product, the formation of the enzyme substrate complex cannot be possible. Okay, now let's try to break this entire scheme into two separate reactions. So what we will get? We will get enzyme plus substrate is equal to enzyme substrate complex, that is the reaction number 1, and enzyme from enzyme substrate complex, the enzyme plus product, that is the reaction number 2. Okay, so now here one another important point for your MCQ exams, that is the Michaelis Menten equation is only applicable for the single substrate enzyme reaction. Okay, that is very important thing to remember, friends. Okay, now we will going to talk about some important notation that will help us to understand the upcoming things. First of all, this one tells us about the free enzyme concentration. That means enzyme who have free active site for the new substrate. Okay, ES means the concentration of the enzyme substrate complex. ET means the total enzyme concentration, and the ET will be the sum of ES plus E, and that is obvious, right? E means the free enzyme concentration and ES means the enzyme substrate complex. Okay, so if we try to add these two, we will get the total enzyme concentration, right? And that is the thing. Okay, now, and this one is the concentration of the substrate. Okay, so now we will going to start to derive the equation. Before that, I want to mention what is the equation. So we will going to derive V0, that is the initial velocity, will be the maximum velocity substrate concentration by Km, that will be a constant. We will going to derive it along with the substrate concentration. That is the equation to derive. Okay, remember it. And this equation is very important for you for any kind of mathematical question that comes in your biochemistry along with your biomath. Okay, so the first point is the initial velocity will be equal to the rate of breakdown of the enzyme substrate complex. Okay, that is the first thing. Now the second thing is the rate of the formation of the enzyme substrate complex will be this one. Now how I am telling this, that is important to understand. First thing I have mentioned, that is the rate of the breakdown of the enzyme substrate complex, that will be the product of K2 and ES, isn't it? Because when the rate constant is K2, we get enzyme plus product. Okay, and similarly the formation of enzyme substrate complex is the product of K1 and E plus S, right? So that is the idea. Okay, so we can write E as ET minus ES, because I have told you concentration of the E means the free enzyme concentration, that simply the total enzyme concentration minus enzyme substrate complex, isn't it? So this is the number 4. Okay, now we going to derive the rate of the breakdown of the enzyme substrate complex. As here the enzyme substrate complex is going to break, that is why the minus sign here. Okay, that is very important thing, because during the formation of enzyme substrate complex we have not mentioned any sign. That simply means here plus is present. Okay, now try to understand what will come here if we going to write the rate of the breakdown of the enzyme substrate complex. Okay, got it? That it will be the product of the K2 and ES along with the product of the K minus 1 ES, because here also enzyme substrate complex is broken into E plus S. We have to consider it too, right? So that is the thing. Okay, now in steady state condition, this is the condition where the rate of the formation of enzyme substrate complex will be equal to the rate of the enzyme substrate complex breakdown. That means the equation number 4 will be exactly equal to equation number 5. Okay, so on solving the equation, we will get K minus 1 plus K2 by K1 is equal to that big term. Okay, so I have simplified it so you can easily understand it. Okay, so here the important thing is the K minus 1 plus K2 by K1 all here are constant, so we can replace this thing with a one single constant, right? So we have taken the term Km. Okay, so now it is very important to remember that Km is equal to K minus 1 plus K2 by K1. Okay, you may get some MCQ mathematical problems from that one. Okay, and we will also going to talk about this Km in one separate video because it is a very important term. So you have to learn where we have put K minus 1, where we have put K2 and K1, because they can ask you Km just by giving K minus 1, the value of the K minus 1, the value of the K1 and the value of the K2. So K minus 1 plus K2 by K1, you should remember this. Okay, so now this lumped constant, you may also remember about just constant if you want. So this lumped constant Km is known as Michaelis Menten constant. Here it will not be equation. Okay, so it is known as mm constant. Okay, for the single substrate enzymatic reaction. So now where we have left our equation up to that part, right? So now we will going to multiply these two. So Km ES Et minus ES S. Now by solving we will get this one. Okay, I hope you can easily understand it. Okay, now we will going to put this equation number 6 on equation number 3, and equation number 3 was V0 is equal to KT ES. That is the initial velocity of the reaction is the rate of the breakdown of the enzyme substrate complex. Okay, so now we will going to put ES, the value of the ES over here. What we get this one. Okay, now I have explained you about the what will be when the concentration of the substrate is very high. Concentration of the substrate is very high and Michaelis Menten equation is applicable only when the concentration of the enzyme is much less than the concentration of the substrate. That means at high concentration all the enzyme will be saturated. Okay, that means we can say that the equation that we have derived earlier, that is Et is equal to Es plus E, here the value of E will be 0, isn't it? Because there are no free enzyme available, right? So under such circumstances we can simply conclude that Et will be exactly equal to Es. Okay, now let's try to remember the equation number 3. That is why I have told you that equation number 3 is the main important equation for deriving the Michaelis Menten equation. So we can replace V0 as Vmax, because at high substrate concentration the velocity of the reaction will also high. K2 will be there, and ES we can replace the term ES with ET, isn't it? Okay, I hope you can understand. So K2 and ET, this particular value in the equation number 7 can be replaced by Vmax. Okay, so we will going to replace it. Okay, so upon replacing it we will get V0 equal to Vmax into S Km plus S, and this equation is called as MM equation. Okay, so that is the entire derivation of the Michaelis Menten equation. I hope you have understood it very well. Now there are various assumptions that Michaelis Menten takes for deriving the entire equation, that I am going to talk about in the next video. Okay, so I hope this video will be helpful for you, and please remember the small point that I have mentioned that you should remember. Then it will help you to solve any kind of problems from Michaelis Menten equation. We will also going to solve some problem too. You don't need to worry about that. Okay, so this was the first video from the enzyme kinetics. So I hope this video will be helpful. Thank you.